like to introduce Brighton Hurdis, who will be presenting Fighting Route Leaks at Cloudflare. Brighton is a principal network engineer at Cloudflare and traveled from Champaign, Illinois. So please join him here. By the way, this is his first time presenting at NANOC, so excited for that. So please welcome Brighton.
Thank you. Thank you very much for the introduction, and I'm very happy to be here. So as said, I'm Brighton Hurdis. I work on the Edge and Backbone Network Engineering team at Cloudflare, and today I'm going to talk about BGP route leaks. And specifically, I'm going to talk about how we detect route leaks that impact our prefixes and our customer prefixes, and some of the complexities and the more complex BGP relationships that we have to account for while we do so. Before I get started, this talk is a collaboration between myself and Mingwei Zhang. Mingwei couldn't be here today, but he has done a ton of work on route leak detection, so I just wanted to make sure to give credit where it's due. Now, without further ado, let's talk about route leaks. So first off, what is a route leak, and why do they matter? So I know that a lot of us are very familiar with what route leaks are because we've been impacted by 1 or 2 or 300 of them. But for the more lucky folks in the room that haven't been, let's talk a little bit about what a route leak is. So a route leak, as defined in RFC9234 is the propagation of a routing announcement beyond its intended scope. And the key phrase for the rest of the talk is really going to be intended scope, because we are going to look at some cases where the intended scope isn't that clear, or we need to dig a little bit more in to understand the intended scope of the prefixes we advertise. But I wanted to go over a really quick simplification of a route leak that I hear and I like a lot. If you are a network and you take a BGP announcement from another network, and you take it and then you send it on to another network, and neither of these two sides are paying you for service, then you are leaking routes. The rules of BGP and our business relationships, you should not take a route from a peer or provider and then take it and send it to another peer or provider of yours. That would be a route leak. So, very simple. It fits and describes most of the route leaks that we see fairly well, but we're going to look at some more interesting cases. But why do we care when a route leak happens anyway? What's the big deal? Why do I care when they happen? Well, let's look at the most typical type 1 hairpin route leak, where a customer is taking prefixes from one of their providers, taking them, and then sending them to another one of their providers. And just a quick show of hands, who has actually accidentally caused one of these route leaks before? Be brave. I'm on that list. I know I am. Jeff is. Because this is easy. It's one misplaced permit or accept term, and you're leaking prefixes between your providers. And when this happens, the customer is going to get a lot more traffic than what they'd bargained for. They probably have not provisioned the amount of ISP-facing capacity to handle all of the traffic they're about to receive. So there might be congestion. They might not have even configured the ACLs on their routers to accept all of the destination prefixes they're about to get traffic for. So this is going to be a tough time. And then we have incidents. And as network operators and businesses, we have to go explain to our customers why they were impacted. And these aren't fun conversations to have. It goes something like, hey, my customer, you were impacted because this thing on the internet happened. This thing in the BGP happened, and it wasn't my fault. It wasn't my fault. It was this network in Pennsylvania's fault that happened to leak prefixes to someone and they got accepted, and your traffic went there instead of coming to the best path. So we don't like having these conversations. So we know what a route leak is. We know what the impact of them are. Let's talk about the network that we want to detect route leaks for. And in our case, it's the Cloudflare network, so we need to step through the types of prefixes we advertise and the BGP relationships that we have. So the first, it's hard to talk about Cloudflare and BGP without talking about Anycast and Unicast. So I'm not going to spend much time here, but Anycast, as many of us probably already know, is when we advertise all of our IP prefixes from all of our global data centers with the expectation that we take in traffic from the end user at the nearest data center to them. So sitting here in Arlington, hopefully our traffic to 1.1.1.1 or any other Cloudflare Anycast service is going to DFW, to the nearest large metro data center. If it's not, call me out later, not now. Now, I wanted a visual for Anycast that's a little different. I didn't want the multiple rectangles that represent servers and an arrow going to the closest data center. I wanted something with BGP. It's a BGP talk after all. So here's what the tier 1 propagation of an Anycast prefix looks like from our perspective. And you can see that almost every tier 1 has Anycast from us directly, except for one of them that happens to have it indirectly. Now let's compare that with an example Unicast announcement. And Unicast, it's important because this is an example Unicast prefix. Depending on which data center the Unicast prefix lives in, we could have a different graph for every Unicast prefix. So in this case, we know that one Unicast IP lives in one data center on one server, and in this case, the data center this one lives in has a few tier 1 providers in it, and they're doing the heavy lifting to get the prefix to the rest of the transit-free zone. So you can see already the difference, the obvious difference between Unicast and Anycast announcements. Now, let's see how those map to our BGP relationships that we have with other networks. And the first is one that we're all going to be extremely comfortable and familiar with. It's what I would call a full or a true transit provider relationship, where we advertise Anycast or Unicast prefixes to a particular network, and the intent is for them to send those prefixes everywhere, to all of their peers, all of their customers, and to their providers if they happen to have providers. And I say send our prefixes everywhere with an asterisk, kind of, because we might be doing some BGP community-based steering to keep Anycast within a particular region. We might be tagging for a particular network to keep prefixes in a region to prevent trombones during certain failure scenarios. So the next is another that we're all very familiar with, which is regular peering. We advertise Anycast or Unicast prefixes to our peer, and we say, hey, send these prefixes only to your downstream customer cone. Do not send these prefixes to your peers or providers, otherwise that would be a route leak. So there's nothing special here. We're all familiar with these relationships. We're all familiar with the business and BGP policy intent that is associated with these. The more interesting and fun case is when we mix them together. So this is what a mix of transit and peering relationship would look like from the Cloudflare perspective, where we advertise Anycast to a BGP neighbor network, and we say, hey, for Anycast, be a peer. Take our Anycast prefixes and only advertise those to your customer cone. Don't send those to your peers and providers. However, for Unicast, take those prefixes and be my provider for those. Take Unicast and give me global intranet connectivity. So this would be extremely common for like an embedded cache type of deployment, where we want to serve a particular partner network's users and eyeballs with Anycast, but we also need global Unicast reachability to get content and get to other data centers or whatever we need to do. So this is the complex peering case that is hard to account for when looking for anomalies, route leaks in AS paths. So from there, we know what we need to account for. We know if we're going to detect leaks, we need to know what the relationship between ASs is. We need to look at an AS path in every adjacency in there and know what the relationship between the networks is. However, we know that we have the complex case from the last slide where the AS relationship is different per prefix. So Anycast versus Unicast, we need a different AS relationship. And the AS relationship can also vary per location. We might have a transit provider relationship with a particular AS somewhere in one region, region A, and we might have a peering with that same network in a particular different data center in a different region, and we'd like to be able to account for that as well. So how do we do it? How do we implement that? So let's take a look at the extremely 100,000 foot high level view of what we're going to do with route leak detection. Obviously, we're going to have BGP updates. We're obviously going to need to look at BGP routes and AS paths and take those and put those through the route leak detection logic. Within route leak detection, we're going to get some AS relationship inferences, some educated guesses and ideas of what the relationship between networks are. But we're also going to build in an internal ground truth, a 100% confidence level of what the intended scope is for some announcements to account for the complex case. And then at the end of this, we want route leak alerts that have few false positives or false negatives for our operators. So I don't think this is going to be surprising in terms of where we get the BGP updates, but we have MRT files from route views as well as RIPE-RIS MRT archives. And then to a certain extent, we've started using RIS Live in our own internal BMP view of BGP updates to have more of a real-time aspect to our detection and our alerting. But for the MRT files, we clean up the BGP updates, we pull the BGP updates out and form a tidy stream that we can use in route leak detection. Then we know we need those AS relationship inferences. We need to infer what those relationships are between networks. And ultimately, we're looking for, are they a peer-to-peer relationship? Is it provider to customer? Or is it customer to provider? And we use a combination of data sources for this. One we use is the CADA AS relationship data, which is really great to have, and it's awesome to be able to use it. We also have some open source BGP kit AS relationship data, where BGP kit more or less keeps a historical view of who is upstreaming who else up to the tier 1 layer to try to put together some inference. And we can compare and contrast those two against one another to try to get a little bit of a confidence score of inferences. But the key is inference is going to be inherently unreliable, especially with the complex BGP relationships. So we want to do better for at least part of the AS path. So to do that, we're going to apply some internal ground truths. For unicast prefixes, we're going to stick with the well-known truth that unicast prefixes belong or they originate from one single data center. And each data center has a internally well-known set of upstream providers. So we can basically pair together which unicast prefixes live in which data centers and which providers serve those data centers. So at the bottom, we have a flow that more or less looks like we take a unicast prefix, we see which data center it belongs to, we see which upstream providers serve that data center, and if an AS is on that list, they get marked as provider of ours. If they're not, then they default to a peer-to-peer relationship. So there's some complexity there, but it's not too bad. It can at least be all put together with internally well-known knowledge. The Anycast case is much more simple than that because we really only have a handful or a little more than a handful of ASNs that should be able to be our provider for global Anycast. If the AS is not one of those, then we're going to default to treating it as a peer-to-peer relationship. So that flow is extremely simple. We check against a static list of Anycast global providers to figure out if someone's a provider or not, and if they're not, then they're a peer. So at the end of that, we end up with this. Top line is that Anycast check against a static upstream list. The bottom line is that slightly more complex unicast prefix, which data center does it belong to, which providers serve that metro or that data center, and then you figure out if they're a provider or a peer from there. So at the end of that, what have we bought ourselves? We have 100% confidence in what I would call the penultimate hop relationship with ourselves. Folks that are familiar with MPLS will know the penultimate hop popping router, the PHP router. It's probably one of my favorite phrases in all of networking, but I'm reusing it here to describe the second to last AS and their relationship with us. Simplified, our direct BGP neighbor, we know what the AS relationship is for every prefix, Anycast, unicast, and location. So let's look at an example alert that we would have that would be sent to our operators. On the left side, we have the QRater folks that put a social media post out saying, hey, AS9304 is leaking over 50,000 prefixes from some peer provider of theirs to other peer provider of theirs. And on the right side, we have a snippet of our own internal alert saying, hey, our AS9304 peer is leaking our routes sent from peering up to their upstreams. And we would have a more detailed view of which route leak type it is. In this case, it's a type 4 route leak. We have the timestamps, the full AS paths, the amount of affected prefixes and observed BGP messages associated with that route leak, and a bunch of internal metadata about the prefixes and some debugging tools if we would need them. So now that we've seen route leak detection, we've seen what the end product alerts are, let's kind of go over what the status quo of some of our current tools are for actually filtering out route leaks. This is not meant to be an exhaustive list. I've kind of handpicked the more simple or popular or just the ones I wanted to mention. But the first I wanted to go with is peer locking. But in this case, I wanted to call out the peer lock light or the big networks filter that Job had originally mentioned at the link at the bottom with a slide deck there. But it's extremely simple and effective, where you say, I'm pretty unlikely to have a tier 1 customer. That's a pretty good assumption. And if you stick with that, you can say, I can pretty much reject any AS path that contains a tier 1 AS from my customers. Because then you know that the route has gone down and now it's coming back up. It's created a valley, so it's a route leak. You can do the same thing with your peers for the most part. You would need a separate policy for your tier 1 peers, but for non-tier 1 peers, you can kind of do the same thing where you say, I should not see a tier 1 AS from any of my peers, and you can just reject those. And this one is one I hope that we're all already using, which is the maximum prefix limits. The source of truth is generally peering DB, where we basically go on there as networks and say, hey, from my AS, accept 200 prefixes from me. And then you can apply those limits. And it's effective against what I would say is a full-ish table leak, where if I'm supposed to send you 200 prefixes, but I send you 200,000, you should probably tear down the session. That's probably a route leak. Good indicator. It's not effective against targeted route leaks. So if I just wanted to, or if I was a malicious party and I just leaked you a subset of prefixes in a targeted manner, this isn't going to help very much. So now, one of my favorites, let's talk about IRR AS sets. Not to be confused with the recently deprecated BGP AS set and the fancy curly braces in a BGP AS path. So this is when you group ASNs together for reasons. Not necessarily reasons that make sense is the key. AS sets, one of the ways you would use it is, hey, here's my AS set, and it contains my downstream customer ASs. Please accept routes that originate from those ASs from me because they're my customers. And that's great. But the problem is AS sets are based on trust, which means they're more or less not reliable at all. And anybody can add whoever they want. Doug Midori did a talk at one of the most recent NANOGs where he went over excessively large AS sets. And if you look at the table that I've put here on the slide, on the very right side, you'll see something that's a little off about the AS cone size of some of these AS sets. If you look at it and you're thinking, hey, I thought there was only 80,000 or so globally routed ASs on the internet, you would be correct, and these contain over 100,000. So it's a pretty good indicator that someone's either up to no good, or they just are throwing everything in their AS set, or it's somewhere down the line, it's one of those AS sets, and they're just inheriting one another. But it's hard to use that for route filtering. So, Brighton, you're telling me about all of these problems with what we have and how we filter out route leaks. What do we have coming up in the future? Is there any hope? So, BGP Autonomous System Provider Authorization. Say that 3 times fast, or just say ASPA or ASPA. Last I checked, the verification draft for ASPA was on draft 20-something. And it's when we create signed ASPA objects in RPKI is the idea. And instead of the AS set approach, where it's the provider saying, hey, here's my customers, it's the inverse. Hey, here's my AS, and here's who I authorize to be my upstream. So theoretically, it's a much better way of having a trustworthy source for validating and invalidating route leak paths. Now, as it pertains to the complex peering talk, or the complex BGP relationship example that I went through, there is no prefix-level granularity in ASPA. So to get the most out of this, kind of similar to AS set memberships, you would really need to express your BGP intent at the AS level. So going back to that Anycast and Unicast example, maybe you have a primary AS that contains Anycast announcements, originations, and peering, and you have a separate AS that you use for that special Unicast intended scope. And then from there, you can kind of keep your ASPA object and your AS set memberships cleaner. Now, the next is one that has some increased attention from at least the vendors lately in terms of implementation. It's the BGP roles and the Only-to-Customer attribute in RFC9234. And essentially the idea is we build in those business BGP relationships of peer-to-peer, provider-to-customer, customer-to-provider, and some of the IX route server and route server client roles into BGP itself. And from there we can do things like, when I advertise routes to a peer, I'm going to say, only send these to your customers with the OTC attribute. And if they're compliant with RFC9234, then they'll do so, and they won't leak those upstream. However, if you're sending routes to a provider, you would not send OTC because obviously that needs to go upstream to provide you service. Implementation-wise, since I did this talk in Chicago at ChiNOG back in May, and now we've gained Junos and Junos Evo to the list of implementations on routers. So good job, Juniper, there. Please, everyone else, that any of the vendors in the room follow suit and implement RFC9234 so we can start preventing route leaks, or at least accidental route leaks. And I did want to call out that RFC9234 has this section 6, additional considerations, and in there they call out complex BGP relationships. And they say, hey, if you have a complex BGP relationship where you might have a different intent or intended scope based on the prefix, we're going to say vendors, hey, you should implement within policy the ability to attach OTC or strip OTC. So going back to the Anycast versus Unicast example, I might advertise Anycast at that embedded cache node data center. I might advertise Anycast with OTC, send these to your customers only. However, for Unicast prefixes, I might strip OTC because I want them to send those upstream. So just keeping in mind there is support there. There's probably really fun ways that could be manipulated and go extremely wrong, but just wanted to call it out. And with that, I think I've left exactly 5 minutes for questions, if anybody has anything. Thanks.
If Houston A. Penick, you think ASPA has a hope in hell? And I'm like, the reason why I say this is that there are two problems flying around inside this space. One is topology, which ASs peer with which ASs, irrespective of the whys. And you've pointed out that there are complex relationships at times where I'm neither a customer or provider for all my prefixes. It varies, right? So ASPAs are kind of weird. And then you've got this other thing around OTC, which is a policy instrument on a local context. It strikes me that ASPAs don't actually fill a useful role here. That realistically, policy is incremented peer by peer by peer. It's an OTC styled thing. And if we wanted to understand topology, which ASs should be seen as adjacent in a path, that's not a policy problem, that's a topology problem. And realistically, if we scrapped ASPAs and simply said, I peer with you without saying why, we'd have a more flexible instrument to actually then apply policy on the top. How would you react to that in terms of your quest, trying to understand when do I see a leak?
Yeah, no, that's a great point, and I think ASPA comes with its complexities, plentiful in complexities. But I will state the obvious and say that RFC9234 is really effective against accidental route leaks. It's not going to do anything for the malicious party that just wants to strip OTC and do wild things. So we need something that's authoritative in terms of the AS relationships, but cannot be easy manipulated like the OTC, I would say. I'm not sure if I've answered your full question, but I definitely hear your concern.
But you exposed a really fundamental question. Is a policy violation intended to be policed remotely, many ASs away, or is it realistically a matter between the two folk who are actually doing the peering? And that, I think, lies at the heart of this discussion. Particularly, it goes into the realms of CIDR and CIDR ops, as to should policy be globally visible or locally applied and visible? And I'm not sure we actually understand that 40 years later.
Yeah, no, that's a terrific point, and that brings me to some doubts about having a mix in the current state of things, having a mix of intent with just a single AS. So our case of Anycast and Unicast, it's extremely dangerous, or it's extremely difficult, rather, to have those mixes of intent unless you have something that's driving the prefix level things like the OTC or anything like that you can rely on. And that's the key, rely on it.
Thank you.
Yep.
Hey, Aaron Stroman here with JSI. Just maybe a naive question. Is there a reason you couldn't just attach, like for route leak detection, like attach random communities to various advertisements you're doing and use that as part of your monitoring?
Yeah, I mean, like we definitely collect communities that we advertise, both large or regular sized communities, but they're always going to be stripped at some point, or it's very likely that they're going to be stripped at some point. So it's not a reliable mechanism when you have collectors that are somewhere on the intranet of detecting route leaks. Now, can you do it and can you try doing it? Absolutely. Will it be effective to the level we need to alert on? No way.
Hi, Adam Korab, Worldwide Technology. Question is, do you see ASPA as a complete replacement for IRR and ASCET, or do you think they will be intertwined in perpetuity or perhaps a migration period?
Yeah, no, that's a great question. I don't think it's going to be a direct replacement, let alone the time it's going to take to actually be adopted and used. I think it's going to be a tool in the tool belt. It's nice to be able to say, you know, we hear Jeff's points, right? But it's also great to be able to say the inverse of an AS set. Hey, here's my AS, and who should be authorized to be upstream of me? Whereas, compared to relying on a provider and them being able to say who their downstreams are. So something out of band or off box to do that is nice to have, for sure. Will it be a full replacement? I don't think so.
Thank you.
Thanks, everybody.